Hello everyone. In this video, I'm just gonna explain how we can extend our agentic AI interaction with the external system, and the most commonly used system which we're gonna integrate in today's video is interaction with the database, so that you can just write your task in a plain English language which requires to interact with the database to get whatever kind of data you want to extract without even worried about writing a complex SQL query by yourself, and then it is going to just produce the output in a CSV file as well, right? So how we can do that, right? So before jumping into the code implementation part, I would highly recommend you to watch my previous video so that you can understand how, I have built my first agentic AI with the help of a model context protocol. And you can find the link in the description for the previous video as well as on your right top of the window. Right. So let's get into the pie chart and see this is the code base if you have following along with the previous video. And this is a simple agent file where we have three methods. One, this is the internet will get time. Then we have a think method, and then we have a run method, right? And these are the two servers like calculator server and the file system server. The next thing which we're gonna add here is we're gonna add a new file and we're gonna call this as a database. Let's go server, right? Now what we have to do, we have to allow our agent to interact with the database through the MCP client, right? So what I have done is I have written a simple code, which I'm just gonna explain you. Let me just quickly copy this code and paste it here and show you what we are doing. Since we have to use a PostgreSQL, so I'm using this PSY library, right? You can find all these information in my GitLab repo. You have to raise a request with me. I will just invite you to the repo, right? This code is already familiar. This is what you have to do. The only additional thing which we have, like these two things along with this Python.environment library, through which we are just loading the environmental variable, right? So this is how the environmental variable looks like. So this is the database URL which you need. Here we have a user ID, then the password and the local host, which is host, and this is my DB name. How you can set up with this credential? I mean, I'm using Postgres with the Docker container. So this is the command which you can utilize, and you can find this in my GitLab repo as well. Right. So this database is already set up and it requires some table to be generated like customer orders, item, and these kind of thing. You can simply see we need some internal initialized data. So you can just get all those information, from my GitLab repo as well. Right. So likewise, we have all some initial data for all these table, and I'm going to show you how once we have this server up and running, like the database server, then how whatever the task we are going to request it to our agentic AI, how it is going to decide whether it has to interact with the database or not. Right. So now coming back to the code part. So these are the two additional library like PSCOP G binary, and then this Python dot environment, which help us to load the environmental file. This is where we are loading the environmental file. So since we have only one variable in this, right? So that's the reason we are just loading here. And then through this OS module, os.environment, we are actually just loading this. Right. Then this is again the same app initialization for the server based on what we have what class we have imported from the MCP server module. Then we have this execute query, and we have used this decorator so that, when client is going to request to the server, then it will know what all tools to look for. And this is execute query is the something which is going to be the tool name, which, server will look when, the client will raise a request to execute something on a server side. Right. So here we have some validation cross check. The very first thing what we are saying is we are not allowing to just hit a multiple queries, and that's the reason we are looking for semicolon, because that's the way we segregate multiple SQL scripts. So that's the first validation which we are doing, which will increase the security of our logic. The second thing, we are only allowing a select operation to happen on our database. So we are checking whether the query contains the select or not. If it doesn't contain, the select, then it is going to stop that. I know if we have an insert with select, then definitely it will just bypass, but we can just make this validation more stronger as well in the upcoming section. Just here to give you some kind of sense what kind of validation I have put together. Then we get this, database URL from the environmental variable, and then we just check whether this is set correctly or not. This is okay. And then if you just see here what I'm doing, I'm just trying to define a curve. So basically first I'm making a connection through this connect. From where I'm getting this connection, this is async connection. If you just come here, we have this async connection from PSYCOPG2 library, which allow us to make the asynchronous connection. And then we have this method connect, which require a connection listing, and we are passing that. And then we are async with await. So basically we are just using async with await context, so that once we are done with the execution, automatically, this context will take care of closing all the required connection cursor and everything. Right? So we don't have to explicitly do that. Once we have a connection made, then we are just calling from this object to cursor, right? And then once we have this cursor context, then we are executing a query, right? So if you don't have async, you can simply write to just make the connection first, create the cursor, and then execute the query, which is a standard way. But here we are using async one because that is how these, application has to be built, right? Just to have, more optimized utilization of our resources, and we are not blocking our application out. Right? So once this is done, then we can just return whether the query is executed successfully or not. So we are just checking whether the response we are getting, which has some records or not. That's the validation we are doing here. If this is not blank, then we are actually creating, actually just getting all the columns, and then we are just creating a result through fetch all, which all we know. And then we are feeding back the rows, right? And these are some exception handling. So the code is very straightforward, right? And this is where, if you just see, we are using a transport as a standard IO, which is, actually calling all these Python, like MCP client and MCP server in the sub process of Python, right? So that's pretty much it, which you have to add here in a tool. Now, you don't have to interact, with the database through the agent file itself, that what we used to do in the previous version. Now, there are only few changes which we need to do here in our agent, So now you will understand what kind of advantage we are getting by having this MCP implementation in place, right? How less, impact our agent is going to have whenever we are going to add a new tool to the server side, right? So now the very first thing, if you see here, we have two, tools added here. So now we have to add the another one, which is related to the database. And this is the line which we need to add. So simply we can say, okay, what we want, we need a database. This is the Python based, code. And then this is the server where you can find, this is the location where you can find this server, because client needs to initialize that or create the session after the initialization, right? That's the first change. And the second change which we have to do in a prompt. Now we have to make our prompt a little bit more intelligent so that it can understand whether, based on the task, whether it has to connect with our database or not. And then we are going to make it a little bit more smarter based on what kind of objects we have on our databases. So we have these 4 databases, right? We can quickly check. So we can simply just, do plus, and we can simply say customers, and we can see what kind of, columns we have. Same thing we can check with, other tables, and, those are the information which I use to just build the prompt, right? So what are the changes we have to make in a prompt? Those are very simple. The first change which you have to make here is, like, if you just look at the prompt, what we are doing, we are just defining some external server. We are saying, okay, this is server, this is a tool, right? So if you just see, this is pretty much same like what information we have on a server side. Now, since we are adding a new server, we have to add this information. Our server is going to be database, then our tool is execute query. This is a pretty much same like what we have here, right? It's the same relationship. I hope you are making sense how the things are integrated, right? The next thing which you have to do, now we have this internal tools, and then we have to tell, the large language model what kind of database schema we have, right? So here what we can do, we can add this information. Now that's the only changes which we have to do, because this run method, which actually after the thinking, it start acting on those small acting on the task, small activities, right? So this is already very generic, because if you see what it does, is take this server to manage, and based on what response, thinking, process will provide to us, and based on that, it just start executing in the comment section. That part I have already explained in the previous video. We are using Agentic Stack, which actually takes care of creating all the servers, and once we are done, it takes care of shutting down all those servers as well. right? So those are the few changes which you need to make. Now you can understand what minimal changes you have to do in an agent to have this new server integrated to the agentic AI, right? So once now all we need to do is to run our Python application, right? So once this is done, probably, if I haven't make any mistake, then we can, you know, okay, so let me quickly run this. So now you can see this is the application which we are getting. Now, what I have done is I have just created a high level flow in the HTML code. And this is the very first question which we're going to ask, right? So that I can quickly explain you what will be happening behind the scene. So what is the name and the price of a product with ID 2? So what we want a product which ID is 2 and we want a name and the price. And then once you have that information, then I want you to save that into the product underscore detail.csv. That's the only plain text you have to write. And then automatically agentic AI will think about it, what kind of query needs to be prepared, how it has to be executed and against which server it has to be executed and what method or the function needs to be called on the server side. And then again, it will come back and see what is the next small activity has to perform so that the complete task can be done. That I have explained in the previous video as well. So let's quickly run this, right? Now I can just quickly do the explanation because it is going to take a little bit of time because it is going to make first, try to think, right? So what we have done, this is the first thing which we have done, right? So we have just given our task where we are asking, okay, what is the name and the price of a product with LV2? Please create a product details CSV to save the result, right? Now, once we just enter this by running a jump button, then what it does, it send this request to the LLM. We know that, right? Then LLM try to understand it has to write something in a product details CSV, but how? It cannot write straight away because the result which needs to be saved, that is not yet there, right? Then it's figure it out, just do the analysis and figure it out. There is a first step where the database tool needs to be used, and this is the JSON it is going to create. It is the same JSON which it does create for the very simple task which I showed where calculator is required to be done because we have to perform some numerical operations. Right now here, since we have some database interaction, automatically this is where the Gemini LLM intelligence will come to the picture. We don't have to think. Usually if we get this question, then we have to think what kind of query has to written, and now all the thinking will be happening through the Gemini LLM. And this is the query which is going to return, right? So let me just quickly run this on a backend and show what kind of result we are expecting. We are expecting product B with 25.50. This is what we have to verify on our output side. Once this first task is done, then what it does, it's just try to see, so basically once LLM thinks, okay, this is the task which has to execute, then this will create a JSON, which JSON is going to just goes to the run method, and that is where the MCP client will come into the picture, and it will just try to understand what kind of JSON it is expecting. And I think I explained this, how this entire, workflow happens. This is where, the entire, once it received, the task, then it starts accepting those JSON file, and the main thing where it is just thinking, this is where it is thinking. And then once we have the action, basically the JSON which I just showed you on a HTML file, this one, and then it's try to see what we have in that JSON, whether it has an answer or not, because until or unless this is done, the answer JSON will not be created. I think I have explained that, and this is where we have these three different JSON in our prompt, right? If it has to make the external tool communication, then this JSON will be returned. If it is an internal one, then this will be returned. And if the final result is there, then this JSON will be built by written by the think method. And then this is going to be the input for run. And this is where it's checking whether the answer is in my JSON response or not. In the first task, it's not going to be there. Then it will check whether the tool name is there or not. Then it will find out tool name is there. Then it checks whether it has to go to the external system where it has to, talk to the MCP server. Then, it's checked whether the server keyword is there or not. Once it is there, then it just try to enroll that server to the client. And then through the session, which we have created earlier, where it's, just calling this method, feeding in the arguments and the tool name, from where it gets the tool name from the JSON, because in JSON, we have the argument as well. And here it is expecting argument in this format where we have to provide a query. right? So once this is done, which is happening in our await, so we are using await. Basically, we know it's an async methodology, so we have to use await so that we can just get the answer with this in an asynchronous method. Once we have this data, then all those things are very straightforward, which I have already explained. So if you understand the Python code, then this logic is very, very straightforward, right? You can come back here and you can see here the first all these server was active, and now take async exit has exited and ensure all the tool server. And now that's the beauty of utilizing this async exit stack over here, right? Coming back to the application, right? And see what response we are getting on the application. Now we can see the very first step here. It has to figure it out. This JSON, this is what I have explained. So automatically Gemini LLM based on my task, it figures it out. The first step should be to make a connection to the DB. How it can do that? It needs to just go to the database server and execute this function. And this is the argument which it needs to pass. And then this is the response. And that is what we are expecting. We are expecting the ID2 should be for the product B and the price should be 25.50. So that's the first step which Gemini LLM actually decided for the MCP club, right? And then the second step is, to just, use the file system server because it has to save the data into the file, right? So which tool it has to use? It has to use the write to file because we have to save the data. Again, just think about it. All these kind of thing, Gemini LLM is thinking and deciding. It is actually just thinking like a human being, right? It is dividing the task and trying to understand what needs to happen. This is the beauty, and that's the reason I'm saying you, if you can understand how these intelligence things works, then you have to just think more innovative and creative to just use these agentic AI to do anything, whatever you can imagine, right? And then once this is done, then it just saves the data and finally the result is done. And the step 3, where again is try to see whether the complete task is done or not. And then we have this final response which says, I have successfully retrieved the name and the price for the product with ID2 and saved the information in this. Again, this answer is being generated by the LLM, right? What we are saying, we are simply saying your final answer, right? And this is what, we are just seeing here. MCP client make the connection to the server, execute the database. It's then database server receive the request, execute the query against the database, send it back the result. Again, it's things, now the first action has been taken. The second action is to call the file system server. Which function to be called? Write to file, because we have to save, the output of, my previous activity to the product underscore. So now we can see the argument which is required for executing this method, like file name and content being passed here again, which is very intelligent. If you just think, all these things are happening automatically by the agentic AI with the help of a Gemini. And this is the final one where agents actually says now that everything has been, not everything has been done, but whatever the response server give it back to the client, and then client try to see whether this is done or not, and then it just give the control back to the Gemini LLM, and that is where it's try to understand from the saved stage information, like whether all the small activities for accomplishing a task is done or not. The agent sees all part of the original task are complete, and it thinks one last time to formulate a final answer. So it's again reevaluate, like think, act, and observe to see whether the complete task is done or not. And then finally it decide. This is what the response it has to generate. We have done nothing, right? We have just given them some functions how to execute the query, and rest of that stuff is actually being done by the Gemini large language model, right? So that is what, now our agentic AI can make the interaction with the database based on the plain English language task, right? So that's it from my side for this video. In the next video, I will just add another server where that server will allow our large language model based agent to interact with the web services, right? Or basically the web based data, right? So that's it from my side for this video, right? If you really like this video, give a thumbs up. And if you haven't subscribed for my channel, please subscribe for my channel as well, right? So once again, thanks for watching this. Stay healthy, keep learning new things.